Today we're going to discuss firewalls. What is firewalls? Protecting a local system or network of systems from network-based security threats while at the same time offering access to the outside world via wide area networks and the internet. This firewall may be designed to operate as a filter at the level of Internet Protocol package, or many operate at a higher protocol layer. So why you need the firewalls? The following are the notable developments in the firewalls. The first one is centralized data processing system with a central mainframe supporting a number of directly connected terminals. Local area networks interconnecting personal computers and terminals to each other and the mainframe. Premises a network consisting of a number of local area networks interconnecting personal computers, servers, and perhaps a mainframe or two. Enterprise-wide network consisting of multiple geographically distributed premises networks interconnected by a private wide area network. The last one is internet connectivity, in which the various premises network all hook into the internet and may or may not also be connected by a private wide area network. The wide area network, that is in firewall, it enables the outside world to reach and interact with local network assets. This will create a threat to the organization. Consider a network with hundreds or even thousands of systems running various operating systems such as different versions of Unix and Windows. When a security flaw is discovered, each potentially affected system must be upgraded to fix that flaw. This will require scalable configuration management and aggressive patching to function effectively. This is possible and is necessary if only host-based security used. The aim of this perimeter is to protect the premises of a network from internet-based attacks and to provide a single choke point where security and auditing can be imposed. The firewall may be a single computer system or a set of two or more systems that cooperate to perform the firewall functions. What are the firewall limitations? The first one is this cannot protect from attacks by bypassing it. Example, sneakernet, utility modems, trusted organizations, trusted services, etc. And also one more limitation is cannot protect against internal threats. For example, disgruntled or colluding employees. And other one is cannot protect against access via wide local area network if improperly secured against external use. And also one more limitation is cannot protect against malware imported via laptop, PDA, storage infected outside. Some of the following design goals for firewall is all traffic from inside to outside and vice versa must pass through the firewall. This can be achieved by physically blocking all access to the local network except via the firewall. Only authorized traffic as defined by the local security policy will be allowed to pass through the network. The firewall itself is immune to penetration. This will implies that use of a hardened system with a secured operating system. Trusted computer systems are suitable for hosting a firewall and often required in government applications. The firewall will be focused primarily on service control, but they have since evolved to provide the all four. The first one is service control. This will be determines the types of internet services that can be accessed inbound or outbound. The firewall may filter traffic on the basis of IP address, protocol, port number, may provide proxy software that receives and interprets each service request before passing it on. Or it may host the server software itself, such as a web or a mail service. Second one is called as direction control. This it determines the direction in which the particular service request may be initiated and allowed to flow through the firewall. User controls. Control access to a service according to which user is attempting to access it. This feature is typically applied to the users inside the firewall perimeter. The last one it is called as a behavior control. This will controls how particular services are used. Some of the capabilities are within the scope of the firewall. The first one is firewall defines a single choke point that keeps unauthorized users out of the protected network, prohibits potentially vulnerable services from entering or leaving the network, and provides protection from various kinds of IP spoofing and routing attacks. And also firewall provides a location for monitoring security related events, audits, and alarms that can be implemented on the firewall system. The firewall is a convenient platform for several internet functions that are not security related. These include a network address translator, which maps local address to internet addresses, and a network management function that audits or logs internet usage. The last one it is called as a firewall can serve as the platform for IP security. Next we'll discuss types of firewalls. The first one it is called as a packet filtering firewall. So packet filtering router applies a set of rules to each incoming and outgoing IP packet to forward or discard the packet. Filtering rules are based on information contained in a network packet such as SRC and test IP addresses, ports, transport protocol, and interface. Some advantages are simplicity, transparency, and speed. Filtering rules are based on information contained in a network packet. One is called as a source IP address. These addresses of the system that will originated the IP packet. Example 182.178.1 1.1. Destination IP address. The IP address of the system the IP packet is trying to reach. Another one is called as a source and destination transport level address. This is transport level port number which defines applications such as SNMP or Telnet. IP protocol field. This will be determines the transport protocol. Interface. This is a firewall with three or more ports which interface of the firewall of the packet came from or which interface of the firewall the packet is destined for. The packet field is typically set up as a list of rules based on matches to fields in the IP or TCP header. If there is no match to any rule, then a default action is taken. Two default passes are possible. One is called default, that is discard. That which is not expressly permitted is prohibited. Default forward, that which is not expressly prohibited is permitted. These are the packet filtering examples. Inbound mail is allowed, that is in port 25, but only to a gateway host. Packets from a particular external host are blocked because that host has a history of sending massive files in email messages. In the rule set B, this is an explicit statement of the default policy. All rule sets include this rule implicitly as the last rule. So in the port C, this rule set is intended to specify that any inside host can send mail to the outside. A TCP packet with a destination port of 25 is rounded to the SMTP server on the destination machine. The problem with this rule is that the use of the port 25 for SMTP receipt is only a default. An outside machine could be configured to have some other application that is linked to at port number 25. In port D, rule set achieves the intended result that was not achieved in C. In the E, this rule set is one approach to handling FTP connections. With FTP, two TCP connections are used. One advantage of a packet filtering firewall is its simplicity, and packet filters typically are transparent to users and also very fast. Some of the weaknesses of the packet filter firewalls are: packet filter firewalls do not examine upper layer data. They cannot prevent attacks that employ application specific vulnerabilities or functions. For example, a packet filter firewall cannot block specific application commands. Second one is, because of the limited information available to the firewall, the logging functionality present in packet filter firewalls is also limited. Third one is, most packet filter firewalls do not support advanced user authentication schemes. The fourth one is packet filter firewalls are generally vulnerable to attacks and exploits that take advantage of plot problems within the TCP/IP specification and protocol stack such as network layer address spoofing. Finally, due to the small number of variables used in access control decisions, packet filter firewalls are susceptible to security breaches caused by improper configurations. Some of the attacks that can be made on packet filtering firewalls and the appropriate countermeasures are of the following. One is called as a IP address spoofing, where intruder transmits packets from the outside with internal host source IP address. Need to filter and discard such packets. Source routing attacks, where source specify the route that packet should take to bypass security measures should discard all sources routed packets. Third one is called as a tiny fragment attacks. Introducer uses the IP fragmentation obtained to create extremely small fragments and force the TCP header information into a separate fragments to circumvent filtering rules that depend on TCP header information. Next one it is called as stateful inspection firewalls. A traditional packet filter makes filtering decisions on an individual packet basis and does not take into consideration any higher layer context. In general, when an application that uses TCP creates a session with a remote host, it creates TCP connection in which the TCP port number for the remote application is a number. This is less than 1024, and the TCP port number for the local, that is client application, is a number in between 1024 and 65535. A simple packet filtering firewall must permit inbound network traffic on all these high numbered ports for TCP based traffic to occur. This will create vulnerability that can be exploited by unauthorized users. A stateful inspection packet filter tightens up the rules for TCP traffic by creating directory of outbound TCP connections and will allow incoming traffic to high-numbered ports only for those packets that fit the profile of one of the entries in this directory. Hence, they are better able to detect bogus packets sent out of a context. A stateful packet information as a packet filtering firewall, but also records information about TCP connections. A stateful firewalls also keep track TCP sequence numbers to prevent attacks that depend on the sequence number, such as session hijacking. Next one it is called as a firewall's application level gateway. This application level gateway This is also called as application proxy. This will acts as a relay of application level traffic. A user contracts the gateway to access some service, provides details of the service, remote host and authentication details, contacts the application on the remote host, and relays all data between the two endpoints. If the gateway does not implement the proxy code for a specific application, then it is not supported and cannot be used. Some services naturally support proxying, while others are more problematic. Application level gateways tend to be more secure than packet filters and can log and audit traffic at application level. This is the diagram for firewalls application level gateway. Next one, it is called as a circuit level gateway. This is the fourth type of the firewall, is the circuit level gateway or circuit level proxy. This is a standalone system, or it can be a specialized function performed by an application gateway for certain applications. A circuit gate level relays two TCP connections, one between itself and an inside TCP user, and the other between itself and a TCP user on an outside host. Once the two connections are established, it relays TCP data from one connection to other without examining its contents. The security function consists of determining which connections will be allowed. Usually it will be typically used when internal users are trusted to decide what external services to access. One of the most common circuit level gateways is SOCKS, defined in RFC 1928. It consists of a SOCKS server on the firewall and a SOCKS library and a SOCKS aware applications on internet clients. When a TCP based client wishes to establish a connection to an object that is reachable only via firewall, such determination is left up to the implementation. It must open a TCP connection to the appropriate SOCKS port on the SOCKS server system. If the connection request succeeds, then the client enters a negotiation for the authentication method to be used, authenticates with the chosen method, and then sends a relay request. The SOCKS server evaluates the request and either establishes the appropriate connections or it can denies it. Then UDP exchanges are handled in a similar fashion. The SOCKS server, which often runs on a Unix-based firewall. SOCKS is also implemented on Windows systems. The SOCKS client library, which runs on the internal host protected by the firewall. A simple packet filtering firewall must permit inbound network traffic on all these I-numbered ports. for TCP based traffic to occur. So this will create a vulnerability that can be exploited by unauthorized users.